Hello, grade 9 students. This is the continuation of our discussion on the six trigonometric ratios: the sine, cosine, tangent, cosecant, secant, and cotangent. And by the way, this is our topic in mathematics for quarter 4, week number 1. So the objectives: find the sine, cosine, and tangent of an acute angle. Use trigonometric ratios to find side lengths and angle measures in right triangles and to solve real-world problems. By the AA similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with that same acute angle measure. AA similarity postulate means two angles are congruent to the two angles of another triangle. So that means they are similar. So triangle ABC similar to triangle DEF similar to triangle XYZ because two of their angles are congruent, 90 and 32 degrees. 90 and 32, 90 and 32 degrees. And if they are similar, then the sides are proportional. So BC over AD, AC should say, is equal to EF over DF here, is equal to YZ over XZ. So these are what we call the trigonometric ratios. Trigonometric ratio is a ratio of two sides of a right triangle. So in our previous lesson, I've discussed to you about the ratio of sine, cosine, and tangent, and in order for you to memorize it, just remember the mnemonic Soh Cah Toa. So for sine A, we have with respect to this triangle here in the figure, sine A is equal to opposite leg over hypotenuse. So A over C. Then if our reference angle is angle B, sine B is equal to opposite over hypotenuse. So B over C. Cosine A, adjacent over hypotenuse. So B over C here. And if we have here cosine B, adjacent over hypotenuse. So A over C. Tangent is TOA, opposite over adjacent. So angle A over B. Or tangent B is equal to B over A. So the trigonometric functions can be summarized using the following mnemonic device: Soh Cah Toa. So means sine equals opposite over hypotenuse. Cah means cosine equals adjacent over hypotenuse. Toa means opposite over adjacent side. Okay, remember that. And on a calculator tip. On a calculator, the trigonometric functions are abbreviated as follows. For sine, it's written as sin, cosine, cos, tangent, tan in your scientific calculator. And in trigonometry, the letter of the vertex of the angle is often used to represent the measure of that angle. For example, the sine of angle A is written as sine A. Finding trigonometric ratios. Example, write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredths. So sine J, our reference angle is J, so your opposite side is 60, adjacent side is 11, hypotenuse is 61. Sine J is so opposite over hypotenuse, so 60 over 61 is the answer, or equivalent to 0.98. How about cosine J? Cosine J is Soh Cah Toa, Ka, adjacent over hypotenuse, so you have 11 over 61 or 0.18 is the answer. About tangent K, our reference angle here is K, so the ratio is opposite side over adjacent side, so 11 over 60 is or 0.18. Gets? Now, calculating trigonometric ratios using your scientific calculator. Find the trigonometric ratio, round to the nearest hundredth. Okay, what's the value of sine 52 degrees? All you have to do is to press sin or sine in your scientific calculator, then press 52 equals, and we will have these results: 0.78801 0.107536, or if you round this to the nearest hundred, 0.79. Caution, be sure your calculator is in degree mode, not radian mode. Cosine 19 degrees, you press cos, then 19 equals. The answer is 0.95. Did you get the same answer? I hope so. Tangent 65, we press tan, then 65 equals Answer is 2.14. I hope you get the same answer. So the hypotenuse is always the longest side of a right triangle. That's true. So the denominator of a sine or cosine ratio is always greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers, less than 1. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have any value greater than 0. Find the length round to the nearest hundredths. We have here triangle ABC, right triangle ABC. One leg is 10.2 feet with angle B 15 degrees. Find the length of BC, side BC, the adjacent side. Okay, so if the adjacent side and the opposite side are the sides involved, then what trigonometric ratio, what trigonometric function, what trigonometric function are we going to use? Is sine, cosine, or tangent? Of course, tangent, because the sides involved are opposite and adjacent sides. Yan. Tangent function. Opposite over adjacent leg. Tangent B, opposite over adjacent side. So substitute. Tangent 15 is equal to 10.2 over BC. And to solve for BC, we just divide 10.2 by tangent 15. Or multiply both sides by BC, divide by tangent 15 degrees. And using your calculator, what's the result? BC is equal to 38.07 feet. That's the length of side BC. When problem solving, you may be asked to find the missing side of a right triangle. You also may be asked to find the missing angle. So if you look at your calculator, you should be able to find the inverse trigonometric functions. This can be used to find the measure of an angle that has specific sine, cosine, or tangent. So this time I will teach you how to find the measure of an angle of a right triangle using sine, cosine, or tangent. So if sine A is equal to x, then sine inverse or inverse sine x equal to measure of angle A. Cosine A equals x, then to find the measure of angle A, you just press in your calculator inverse cosine x. Tangent A equals x, then measure of angle A is inverse tangent x. Example, using your calculator, find each angle measure to the nearest degree. Inverse cosine 0.87. The answer is 30 degrees. Round your answer to the nearest degree. Ito yung original answer, 29.54. Ito naman, bale, what did you press? Cos, shift cos. Shift cos 0.87 equals 30 degrees. Yun, 29.54. Ito naman, shift sine. You press shift, then sine, 0.85. 58.21 or 58, simply 58 degrees. Ito naman, shift tan. You press shift, then tan, 0.71. The answer is 35 degrees. Okay, did you get it? That is how we get the measure of the angle of a triangle, of an acute triangle. So, using given measures to find the unknown angle measures or side lengths of a triangle is known as solving a triangle. To solve a triangle, you need to know the two side lengths or one side length and an acute angle measure. Caution, do not round until the final step of your answer. Use the values of the trigonometric ratios provided by your calculator. Example, find the unknown measures, round lengths to the nearest hundred, and angle measures to the nearest degree. So, we have here triangle STR or RST. Hypotenuse 5.7, SR leg, one leg, the longer leg is 5. What is the measure of the shorter leg? So we can solve that using Pythagorean theorem. 5.7 squared minus 25 is square root of 7.49, which is 2.74. So to find the measure of angle R, then we're going to use cosine function. Yes. Why cosine? Because the sides involved are adjacent side and hypotenuse. Okay. Cosine. So cosine R is equal to 5 over 5.7. And to solve for measure of angle R is inverse cosine 5 over 5.7. So in your calculator here, you press shift, then cos 5 all over 5.7. and the result should be approximately 29 degrees. And if angle R is 29 degrees, therefore angle T is 90 minus 29 degrees, 61 degrees. So that the sum of the three angles of the triangles is equal to 180 degrees. Another, find the unknown measures. Round length is the nearest 100 and angle measures the nearest degree. Given angle F in triangle DEF, angle F is 58 degrees, its opposite side is 14. Find EF, the hypotenuse, and angle D. So first to solve is angle D. Since this is already 90, the sum of angle D and F is also 90 degrees. So 90 minus 58 degrees is 32 degrees. So angle D is 32 degrees. And to solve for the leg EF, we're going to use the tangent function, tangent 32. So since D is 32 degrees, tangent 32 degrees is opposite over adjacent side, EF over 14. We can also use tangent 58. Tangent 58 is equal to 14 over EF. So pwede rin yun. So if you use 32 degrees, tangent 32 is equal to EF over 14. If you use 58 degrees as your reference angle, tangent 58 is equal to 14 over EF. Same result will be obtained. So if we use tangent 32, we have EF over 14. Solve for EF, multiply both sides by 14. So 14 times tangent 32 is approximately, the answer is 8.75. And to solve for the hypotenuse DF, we can now use the Pythagorean theorem. 14 squared plus 8.75 squared is 16.51. Okay. Ano na yun? You get the square root now, both sides. And that ends our short discussion on 6 trigonometric ratios. Goodbye, see you next time.